Alright, so today we're talking angles of polygons. Our goal for today is to be able to find and use the sum of the measures of the interior angles of a polygon and find and use the sum of the measures of the exterior angles of the polygons. So we're dealing with interior and we're dealing with exterior today. This one should not be that bad. It should be pretty quick and painless. So a diagonal is a straight line connecting opposite corners on a polygon. So you could choose any two opposite corners. They have this red line drawn in. You could also draw one like here or here or here. You can draw diagonals in anywhere as long as it's to opposite corners. If it's not to opposite corners, then it would just be kind of a side of the polygon or an edge of the polygon. It wouldn't even be a separate entity that needs a new vocab word. Alright, so now we're doing a quick review on shapes. If you don't know the names of your shapes, this is a quick reference tool. Copy it in your notes. Triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6, heptagon 7, octagon 8, nonagon 9, decagon 10, hendecagon 11, and dodecagon 12. And then anything over that is what we call an n-gon. So if it was 34-sided, it would be a 34-gon. Anything bigger than 12, we're just calling an n-gon. All right, continuing on. So polygon interior angle sum. So the sum of the interior angle measures of an n-sided convex polygon is n minus 2 times 180. So big picture, write this formula in your notes. N minus 2 times 180 equals the sum of interior angles. Okay, super important. So n minus 2 times 180 is the sum equals the sum of the interior angles. And n is the number of sides in that polygon. Okay. Continuing on. So, our first problem, find the sum of the measures of the interior angles of a convex nonagon. So first things first, we need to know nonagon, 9 sides. So my nonagon has 9 sides. I know my formula is n minus 2 times 180. So 9 minus 2 times 180 equals 1260 degrees. So find the measures of an interior angle of a convex nonagon. Okay, perfect. So this is the sum of the interior angles of our convex nonagon. Now, continuing. So all we needed was that formula. Now, if they said something like, find an interior angle of a regular nonagon. A regular nonagon means all the interior angles are the same measure. We would do that same first step, but then we would divide this 1260 by 9, and we would get each interior angle of a regular nonagon would be 140 degrees. So just be careful. Be on the lookout for that regular indication. They will sneak that in there on you. So find the measurement of each interior angle of the parallelogram RSTU. So first things first, we would do our n minus 2 times 180. And 4 sides, minus 2 is 2. 2 times 180 is 360. Then we have to add every single one of these interior angles up since they all have the variable x in them. And we're going to set them equal to 360. So let's add these up. So we have, when I add these up, I don't like to write it all out. In my head, what I do is I say, okay, 11x plus 11x is 22x plus 5 plus 5. So that would be 32x. So 32x plus, then I deal with my regular numbers. I have 2 4s. So plus 8 equals 360. That's how I do it when I work with one of these. I just deal with the x's first, then I deal with the regular numbers. So we have our equation set up. We're going to do 360 minus 8, which is 352. And then, so we have 352 equals 32x. So we divide 352 by 32, and we get x equals 11. But we're not done yet, because we have to plug that back in. So what I'm going to say is, since we have two angles that are 5x, I'm going to just label one of them. So I would plug my 11 in, 5 times 11. So 5 times 11. So this angle is going to be 55 degrees. Now I'm going to do the same thing on these other angles. So I'm going to say, okay, we have we have two angles that are 11x plus 4. I'm only going to plug in 11 once. So I'm going to say 11 times 11 plus 4. 11 times 11 is 121, plus 4 is 125. Which, that checks out because these add up to equal 180 degrees, and we'll have the same set of angles over here on this other side. So, if you would prefer, you can go ahead and label all of them. I don't think it's necessary, but I'll do it anyway, just for being thorough, I suppose. Alright, so continuing on, find the value of x. So, once again, this is one that you would do it by yourself in class, but we'll do it together real quick. So we have 25x minus 15 equals 360. So 345 equals 25x. 345 divided by 25 is going to give us 13.8. X equals 13.8. Oh, what has gone atrociously wrong here? So 12. Oh, I see I added those wrong. No, 12. So that should be 12x, 22x, 25x. Oh, yeah. I subtracted it instead of added it, so it should be... We'll just make a quick little edit here. So it should be 375, which should give us a much better number when dividing by 25. So we should have x equals 15, which is a much happier answer. So C. All right, so architecture. A mall is designed so that 5 walkways meet at a food court that is in the shape of a regular pentagon. Okay, so here's one of those problems where they tell us regular pentagon. Find the measure of one of the interior angles of the pentagon. So first things first, we say pentagon has 5 sides or 5 interior angles. So 5 minus 2 times 180, which 5 minus 2 is 3. 3 times 180 is 540 degrees total. Now, it's a regular pentagon. So we have 5 congruent angles, which means we have to divide this total by 5. So if we do 540 divided by 5, I believe it's 108. Yeah, we get 108 degrees per each one of these angles. Lovely, lovely, lovely. This is one that you would get to work on in class. Heptagon, 7 sides. So 5 times 180 equals 900 divided by 7 is 128.57. Yay. All right. Find the measure of an interior angle of a regular polygon. Okay, so the measure of an interior angle of a regular polygon is 150. So 150 degrees is the interior angle for one angle. So now we have to figure out a way to find the total number of sides. So there's a couple ways you can do this. You can guess and check. You could create some sort of big master list of how many, like a 40-sided figure has interior angle of whatever. So here's how I like to do it. I like to set up this formula. This is a formula I would also put in your notes if I was you. So I say 180 minus whatever they give you. So whatever angle they give you. 180 minus whatever angle they give you. In this case, it's 150. Times n. Minus that. Yeah, times n equals 360. Right? Yeah. Equals 360. Okay. So in this case, we have, well, first things first, this formula right here that I just boxed in, that has to be in your notes. Absolutely has to be, because you will forget it. So let's solve this. So 180 minus 150 is 30. So we have 30n equals 360. So we divide 360 divided by 30, and we get 12. So this is a 12-sided figure. Now, if we wanted to double check that, we could say 12. So we could do 12 minus 2, which would be 10, times 180 equals 1800. 1800 divided by 12 equals 150, which takes us back to our original number. All right, so this formula right here with all the green stars around it, pause the video, put it in your notes if you haven't done so already. Continuing on, the measure of an interior angle of a regular polygon is 144. Find the number of sides in the polygon. So 180 minus 144 is 36 and equals 360. So n equals 10. Now, if we wanted to double check that super fast, we would say 8 times 180. 8 because 10 minus 2 is 8 times 180 equals 8 times 180 equals 1440 divided by 10, because it's a 10-sided figure. We get 144 for each interior angle, which is of course what we started with, so the world is all happy and pure. All right, moving on to our last little topic. This is my favorite one. Polygon exterior angle sum theorem. I guess they didn't give us the theorem. I'm giving us the theorem. So, if you add all the exterior angles on a convex polygon, the total is going to be 360 degrees. Every single time. Doesn't matter if it's a 3-sided figure or a 30-sided figure or a 300-sided figure. It's always going to equal 360. So, example, they might give you a problem with all these exterior angles, and quite frankly, it's atrocious and it's just mean. But I'm going to go through this and I'm going to cross these off as I go. as I add up. So 5x, 9x, 15x, 17x, 22x, 27x, 31x. So we have 31 x's. Whoa. Now I'm going to go around and add up my constants. So 5 plus 3, 8, negative 4, negative 1, negative 6, negative 12. So minus 12 equals 360. All right. Now we need to solve this. So add 12 to both sides. 372 equals 31x. So 372 divided by 31 equals 12. X equals 12. Now it just wants us to find x for this one, so we don't actually have to plug this back into each individual angle, which would be brutal. Fortunately, we're just finding x in this case. So, I don't know why my teeth are hurting. So, find the measure of each exterior angle of a regular decagon. So here we are again. They're throwing this regular at us, and they want us to find the measure of each exterior angle of a regular decagon. Well, as we all know, a decagon has 10 sides. So 10 sides, and each one of those exterior angles adds up to equal 360 degrees. 10 sides means 10 exterior angles, so we're just going to call this 10x equals 360. We solve this. 360 divided by 10, so x equals 36 degrees. So each exterior angle would be 36 degrees. Yay. Okay, so now we have one more problem, or we have two more problems, I guess, technically. I'm just going to do this one. So, first things first, go around, add up all your x's. 5, 10, 12, 15, 19, 25, 25x, plus 4, 6, 9, 5, 10, plus 10 equals 360. 25x equals 350. 350 divided by 25 would be 14. Lovely. If we wanted to do this last one just for fun, find the measure of each exterior angle of a regular pentagon. Pentagon, 5 sides. 360 divided by 5, which would be 72. All right, that is all we have for this lesson. If you have questions, please